Hello everyone, I am Shivani and welcome to Civil Series. So this video is about the detailed explanation of Test Series 5, which is about the design of reinforced concrete structure. Previously I uploaded 4 टेस्ट आणि त्या चारही टेस्टला तुमचा खूप चांगला प्रतिसाद असल्यामुळे मी ही आज 5वी टेस्ट सिरीज लॉन्च करते. ज्या चारही टेस्ट सिरीज आपण आतापर्यंत घेतलेल्या आहेत त्यामध्ये पहिल्या ज्या 2 टेस्ट सिरीज होत्या त्या आपण पूर्ण सब्जेक्ट्सवर घेतल्या होत्या. म्हणजे जे 12 सब्जेक्ट्स BMC साठी दिले गेलेले आहेत त्या 12ही सब्जेक्ट्सचे क्वेश्चन आपण त्यामध्ये इन्व्हॉल्व केले होते. नंतर ज्या 2 टेस्ट सिरीज घेतल्या म्हणजे तिसरी आणि चौथी टेस्ट सिरीज त्यामध्ये एक टेस्ट सिरीज होती हायवेची आणि एक होती एस्टिमेशन कॉस्टिंगची. ही जी टेस्ट सिरीज आहे ती घेतोय आपण डिझाइन ऑफ रेन्फोर्स्ड कॉन्क्रीट स्ट्रक्चरची. अशी कमेंट केली गेलेली होती याच्या अगोदरच्या व्हिडिओमध्ये, त्यामुळे मी ही टेस्ट सिरीज घेऊन येत आहे. आणि असंच तुम्हाला ज्या गोष्टीवर किंवा तुम्हाला ज्या विषयावर टेस्ट सिरीज हवी आहे त्याची तुम्ही कमेंट करू शकता. तसा व्हिडिओ तुमच्यासमोर टेस्ट सिरीज 6 मध्ये येईल. आणि चला तर स्टार्ट करूया आपण व्हिडिओला. सो लेट्स स्टार्ट विथ द क्वेश्चन. फर्स्ट क्वेश्चन, what must be the minimum grade of concrete to be used for a reinforced concrete means RCC structural element which is exposed to extreme exposure condition? There are 5 exposure condition. First one is mild, second is moderate, third one is severe, next is very severe, and last condition is extreme condition. In case of mild condition, M20 grade is used. In case of moderate, M25. In case of severe, M30. In case of very severe, M35 grade is used. And in case of extreme condition, M40 grade is used. So here the M40 is given in the third option. So this third option is correct here. Then these are the few tables for more information. So in the question they ask about only RCC, but these are the grade values for PCC. Then the nominal cover, then cement content, minimum cement content and minimum water cement ratio for PCC and for RCC. Okay, then next question. Then second question, consider the following strength of concrete: cube strength, cylinder, split tensile and modulus of rupture. Correct sequence in increasing order of these strength. So for this there is one equation which is cylinder strength is equals to 0.85 times of cube strength. Okay, so here by observing this equation we know that the cube strength is larger than the cylinder strength. Okay, so here for increasing order, first cylindrical strength come and then cubic strength come. But in the first and second option, first they mention the cube strength, then next cylinder strength. Means option number first and second is wrong. But option number third and fourth, B and A is in correct arrangement. Means cylinder is first and then cube strength is latter as per the increasing order. Then in case of split tensile strength and modulus of rupture, split tensile strength gives lesser strength. Okay, always remember that split tensile strength gives lesser strength. So here C is first, then D, B and A. So this is the correct order. So here option number third is correct for the increasing order of strength. Then next question. Then question number third, the nominal mix corresponding to M15 grade concrete. So for nominal mixes there is one table and that table is first the value start from M5, then M7.5, M10, M15, M20 and M25. Okay, there is one trick to remember the nominal mixes here. First write 1 for each grade, then next write from 5 in decreasing order. Here 5, then 4, 3, 2, then 1.5 and 1. Okay, then double the value like this. Right here 10, 5 is double, 8, 3 2s are 6, 2 2s are 4, 1.5 into 2, 3, and here 1 into 2, which is equals to 2. So these are the proportions for the grade of concrete. So here they ask about the M15 grade. So for M15, the proportion is 1:2:4. So here option number first is correct. The next question. Fourth question. The maximum spacing of shear reinforcement as vertical stirrups measured along the axis of a reinforced concrete beam of width 300 mm and effective depth 500 mm with space of 6 meter is. So for shear reinforcement there are two conditions. First condition is shear reinforcement should not be more than 0.75 d. Okay, d is depth. And if this shear reinforcement is more than 0.75 d, then take the shear reinforcement as 300 mm. Okay, spacing of shear reinforcement as 300 mm. This is all about the spacing of shear reinforcement. So here the depth given is 500 mm. So we'll put the given value into the formula. So the spacing of shear reinforcement should not be more than 0.75 d. So first we'll put in this equation 0.75 into d is 500. So this value is nearly equals to 375 mm, but this value is more than the shear reinforcement value, which is 300 mm, more than this. Okay, so because of that, we'll take the spacing of shear reinforcement as 300 mm and which is given in the first option. So here first option is correct. The next question, question number 5. Question number 5 is the minimum eccentricity to be considered for an axially loaded RCC column of size 400 mm by 400 mm with unsupported length 5 meter. So for minimum eccentricity, the formula is unsupported length divided by 500 plus the size of beam divided by 30. So here unsupported length given in the meter. So convert into mm. 5000 mm divided by 500 plus 400 divided by 30. So this value is nearly equals to 23.3 mm. So this is the minimum eccentricity. So your third option is correct. The next question. Question number 6. The minimum stripping time of soffit formwork to beams props to be refixed immediately after removal of formwork. So for this, the minimum stripping time is 7 days. Minimum stripping time is 7 days. So here the 7 days is mentioned in the third option. So third option is correct here. But there are remaining values. That remaining values is first the vertical formwork for column, beam and wall. The timing is 16 to 24 hours. Then second one is for slab. Props are immediately fixed after removal of formwork. The timing is 3 days. Then third, here soffit of slab. Okay, soffit of slab. Then next is soffit of beam, 7 days. Then fourth one, here the props are to be refixed immediately after removal of formwork. So then the timing between props for slab, props to slab. So in that the condition is when span is 4.5 meter or less than that, then the timing is 7 days. If span is more than 4.5 meter, then 14 days. Then next one, fifth, props to, here slab is mentioned, then props to beam. if span is more than 6 meter or span is equals to 6 meter, less than or equal to 6 meter, then 14 days, and if span is more than 6 meter, then 21 days. Okay, these are the stripping times. So this is less or equal, this is for more, this is for less or equal, this is for more. Here the third option is correct. The next question. Then question number 7. The design bond stress 1.5 Newton per mm square is assumed when the development length of Fe 500 HYST bar nominal diameter is 12 mm, which is fully in tension will be. So for development length, the formula is LD is equals to 5.87 Fy divided by 4 tau BD. So this is what the formula for the development length. Here the given values are phi is equals to 12 meter, then tau BD is 1.5 Newton per mm square. Here the tau BD in case of tension is increased by 60%, and in case of compression this increased by 40%. 60% means 100 by 60, and here 100 by 40. The value 100 by 40, the values are equals to here 1 by 6, and this value is nothing but 2.5. So these are the values for the multiplying factor for this tau BD. Then the next given value is Fy, which is equals to 500. So put the given value into the formula. LD is equals to 5 value is 12 into 0.87 into 500 divided by 4 into 1.6, because the tension condition is mentioned in the questions. For tension 60% value is increased, which is 1.6 into 1.5, and the calculation, after calculation we get 544 mm, and this is mentioned 544 mm is mentioned in the option number first. So your first option is correct. The next question. Then question number 8. For M20 grade of concrete, modular ratio would be. So for modular ratio, the formula is 280 divided by 3 into sigma CBC. For this sigma CBC, this is the table. This is the sigma CBC, mean permissible stresses in compression for bending, and these are the direct stresses. So bending stresses are sigma CBC, and value for M20 grade is 7. So here sigma CBC is 7. So put the 7 into this formula, 280 divided by 3 into 7, and this modular ratio is equals to 13.13. So here the option number 1 is correct, which is 13.33. The next question. Then question number 9. At what stress does the flexure crack appears in the RCC beam made of M25 grade concrete? So for flexure crack appears in the RCC beam, the stress is, formula for that, FCD is equals to 0.7 square root of FCK. Okay, so here FCK is equals to 25. So put the 25 into the formula. So we get 3.5 as a 3.5 MPa as a stress which does the first flexure crack appears in the RCC beam. So here B option is correct. The next question. Then question number 10. In limit state design method, the moment of resistance for a balanced section using M20 grade concrete and HYST steel of grade Fe415 is given by this MOR is moment of resistance equals to KBD square. What is the value of K here? So the value of K here they ask. So the formulas for the moment of resistance are so first we'll discuss about the formulas and then we'll solve the numerical. So first formula is for Fe 250, second for Fe 415 and third formula is for Fe 500. So first formula is moment of resistance equals to 0.148 FCK BD square. Then second, moment of resistance formula for Fe415 is 0.138 FCK BD square. Then last formula for Fe500, moment of resistance is equals to 0.133 FCK BD square. Okay, so here we use this Fe415, which is moment of resistance equals to 0.138 FCK BD square. So here this K value is equals to 0.138 FCK. Okay, so I'll write this formula here. MOR, moment of resistance for Fe415 is equals to 0.138 FCK BD square, and in the question they ask MOR equals to K BD square and they ask about the value of K here. Okay, so for K we take 0.138 FCK and this FCK value is mentioned, which is M20. So here FCK is equals to 20. So 1.138 into 20 is equals to 2.76. So this is the value for the K, and here option number 2 is correct. The next question. Question number 11. What is the minimum area of tension reinforcement in beam when Fe415 is used? So for Fe415, the minimum area of tension reinforcement PT is equals to 0.85 into 100 divided by Fy. So 0.85 into 100 divided by 415 is nearly equals to 0.2%. So here option number D is correct. The next question. Then question number 12. The minimum strain at failure in tension steel having yield stress Fy 250 MPa, Young's modulus given is ES equals to 200 GPa. The limit state method of design is, as per the limit state of design is, so formula for that is sigma S is equals to 0.87 Fy divided by ES plus 0.002. So here Fy given is 0.87 into 250 MPa. So convert this MPa into Pascal, which is 10 raised to 6. Okay. Then next ES is equals to 200 into 10 raised to 9 to convert the gigapascal into Pascal. So after plus 0.002. So after calculation you get the sigma S, which is minimum strain at failure in tension steel, is 0.0030. So here first option is correct. The next question. Then question number 14. The effective width B of flange of continuous T-beam in a floor system is given by BF is equals to L0 by 6 plus BW plus 6 DF, where this L0 represents. So for this L0 is nothing but distance between the point of contraflexure in the span. So your first option is correct. The next question. Question number 14. If Cu and Fy are cube compressive strength of concrete and yield stress of steel respectively, Es is the modulus of elasticity of steel for all grades of concrete. The ultimate flexure strength in concrete can be taken as, so ultimate flexure strain in concrete is third option, which is 0.0035. The next question. The assumption that the plane section normal before bending remains normal after bending is used. So this is question number 15. The assumption that the plane section normal before bending remain normal after bending. The assumption is in both the working state and limit state design. So third option is correct here. Then question number 16. Design strength for M25 concrete in direct compression, bending compression, flexural tension as per the LSM limit state method respectively. So the formulas for these kind of compressions and tensions are: first, for the direct compression, formula is 0.4 into FCK. Then second formula is for bending compression, which is equals to 0.45 into FCK. Then next third formula is for flexural tension, which is equals to 0.7 square root of FCK. 0.7 into square root of FCK. So while putting the given values into this question, so we get this 0.4 into 25, which is equals to 10 MPa. Then 0.45 into 25, which is equals to 11.15 MPa. Then last one is 0.7 into square root of FCK, which is 0.7 into 5, which is 3.5 MPa. Okay, so all the three options are present in the first option. So here first option is correct, which is 10 MPa direct compression, 11.15 MPa, 11.15 MPa bending compression, and 3.5 MPa is a flexural tension as per the limit state method. The next question. Question number 17. The anchorage value of hook is assumed 4 times the diameter of bar if the angle of the bend is. So for 4 times of diameter, the angle of bend is 45 degree. For 8.5, angle of bend is 90 degree. For 12.5, angle of bend is 135 degree. For 16.5, the angle of bend is 180 degree. So here 45 is mentioned in third option. So for this question, third option is correct. The next question, question number 18. At which condition splicing of reinforcement bar in RCC beam is required? So for splicing of reinforcement in the RCC beam, the bending moment should be less than the half of maximum bending moment on the beam. So here the bending moment should be less than, and that mentioned in the second option. So the second option is correct for this question. The next question number 19. The maximum deflection due to load in RCC beam in a building is limited to. So for maximum deflection, the value is related to span of that beam. So here the span by 250 is the maximum deflection due to the load in case of RCC beam. The second option is correct. The next question, last question, question number 20. In a simply supported slab, alternate bars are curled at. So curled at 1/7 of the span or 0.15 L of the span. Okay, these are the two values. In the question 1/7 of span is mentioned. So third option is correct here. So this is about the test series 5, and thank you for watching.